All right. Hi, everyone. I'm Atar Sanane, President of the Society for AI and Deep Learning at BITSCO. I'll be taking an introductory session, a short introductory session now, to just go over what you can expect from this event and yeah, just some logistical things and also a brief overview of artificial intelligence to give a little bit of background and context for the event. So I'll just give me a second. All right, let's get started. So once again, welcome everyone. Sorry for the sorry for the wait, and yeah, we're getting started with the introductory session. So first of all, I'd just like to go over the aims that we have as an organizing team for the symposium. Three main aims. First of all, we want to expose students, especially undergraduate students, to the key trends and directions in modern AI. And the way we're planning to do this is by having conversations with leaders in the field on what they think will be the future of AI in their specific specializations and also in general. This we hope would give an idea of to undergraduates and students who have lesser experience about where the field might be heading and what sort of skill sets to develop, and also expose them to new and interesting ideas which they can explore on their own and also take up as research or implementation directions, innovation directions. So the second main aim being that we also have found in general that it's for many students and early career researchers, getting started can be a big hurdle, especially in a fast moving field like machine learning and AI. And there's a lot of right now, since the field is quite as we know, it's quite a booming field. There's a lot of opportunities and a lot of different avenues you can take. So to give a little bit of guidance and also insights on how you can make the best decisions according to your interests, we have also scheduled talks from budding early career researchers and practitioners who are all doing great in their field and who have some thoughts to share about how you can get started building a career in AI, machine learning, and deep learning. And also, finally, we wanted to bring together the student AI community, especially the student AI community in India. Bring it together, kind of give a platform to allow people to make connections from other colleges, from other institutes, organizations, and also to discuss the key and exciting topics that are happening in AI currently. So these are our three these are our three main aims, and yeah, this symposium is kind of a way to achieve these three things. This is actually the second edition of our AI symposium. We also had one last year, focusing much more on the research aspect of things, with talks from really eminent researchers across the world on their specific research interests. This time we shifted more towards making it a more student-friendly symposium with much more interaction, and also more accessible conversations about things that really matter to undergraduates and students in general. So we hope to accomplish these three things in the next 2 days. First of all, we have a great lineup of senior speakers who will be having conversations and Q&A sessions with. So we have Dr. Gautam Shroff from TCS Research talking about integration of AI into industry. Sachindra Joshi from IBM Research talking about where conversational AI systems are heading in the near future. Dr. Aditeshwar Seth from IIT Delhi talking about AI and technology for social developments and how you can have impact on the ground for the people who need it most using artificial intelligence and technology in general. Dr. Aruna Rajan from Amazon talking about ML in internet industries, and also Dr. Arun Ravindran from BCG Gamma talking about building AI solutions for business specifically and industry. So these will be Q&A sessions where we'll have a moderator from the SAiDL team discussing asking these speakers about key topics in that subfield, and also where they think the field is heading. And since we want to make this as interactive as possible, we'd also like you guys who are attending the session everyone attending the session to feel free to put up your questions and any kind of queries you have that you would like to these speakers to answer in while the sessions are going on. So the moderator can pick those up and ask them along as the conversation flows along. We also have talks by early career researchers to guide those who are looking to get into AI and ML and guide them on how to take decisions that might be best for them. We have Vidhi Jain, who is an incoming PhD student at CMU, talking about how to, you can see the titles, 3 paintbrushes for your research canvas, no apply and network. Sanket Gupta, who's a PhD student at Stanford, talking about his journey, and Mansi Gupta, who's an ML engineer at Twitter, who will be talking about building a career in ML. And just a side note, all of these are BITS alumni from, and those of you who might be attending from BITS, just to kind of shout out to that. We would also be having a social. This is servicing the aim of bringing the AI community together. This will be on a platform called GatherTown, which some of you might be familiar with, but for those who have, this is the first time hearing about it, GatherTown is a virtual role-playing game-like platform where you can control a character in a sort of closed environment. You'll have characters controlled by other people, and you can go up to others, talk to them. You can have your video on, audio on. You can talk to them as if you were in real life, and it's trying to simulate that spatial dimension of interaction that we're really missing out on during these online sessions. So we're really excited to have this GatherTown social session, and we really hope that the AI community from all across India can come together and discuss and get to know each other. Note that we have a limited capacity, so make sure to apply through the registration form on our website. As part of the social, we also will have virtual spaces organized inside our small GatherTown world to discuss different topics in AI/ML, to spark discussion, and also spaces where you can just casually chat with others, talk about research interests, talk about new innovative ideas, and just get to know each other better. So yeah, we really hope this social can bring together the AI community. A few points in logistics. Each session will be around 40 minutes. These, by session, I mean those are talks and conversations. We'll be using 3 different Zoom invites. All of these should have been sent to everyone who registered. One for this morning, one for tomorrow morning, and one for Sunday evening. So if for any reason you can't join Zoom, there is a YouTube. All of these sessions are being live streamed on YouTube. The links for those should also have been sent on through email to all those who've registered. We will also put this up on our website for easy access. And the most important point I would like to kind of emphasize on is that we want these sessions to be as interactive as possible. So please feel free to ask questions by typing them in the Zoom chat while the session is going on. Basically any questions you'd like the moderator to ask the senior speaker if it's a conversation session, or any questions you would want to ask one of our early career researchers, early career speakers. And one caveat about that is since we want to keep the Zoom chat for questions specifically, if you would like to have more in-depth discussions or talk about tangential topics, please use our Discord server, which is much better suited for that. That way we'll keep the Zoom chat for questions and the Discord server for more in-depth discussions. The link for joining the Discord server can be found on our website. And finally, just a quick note, please refrain from any spamming or any kind of inappropriate behavior in the chat. We'd like to keep this session as welcoming to everyone as possible. And yeah, so let's just kind of keep that in mind. If you need any assistance or queries, or if you want to discuss anything with the organizers, you can message us on Discord. We have the tag organizer, or you can email Vedant or me, who are the points of contact for this session. The details for our contact details are in the website footer. So if you need any help, just feel free to email us or message us in Discord. So with that kind of, so that's just basic general points about the what you can expect during the session. For those of you who might be new to artificial intelligence in general, I'd like to go over, just kind of give a little bit of a brief background to what AI is. And one of the, I think, people have been thinking about artificial intelligence for a long time, as you can see from this quote by Alan Turing in his famous paper, The Imitation Game, published in 1950. The first sentence was, "I propose to consider the questions, can machines think?" And people have been asking that question for not just from Alan Turing's time, but from millennia, from ancient Greeks and ancient Indian civilizations, right? And the question is, it's a really intriguing question in that we want to make artificial beings, or that might be going into the sci-fi sense, but we want to create systems or things that can think like we do. And so there's, yeah, so that it's a kind of thing that I think pervades all of humanity, and it's an intriguing question that I think it would intrigue anyone. I like to think about AI as kind of in these two kind of extreme points. One way of looking at it is attempting to replicate natural intelligence and learning that we humans possess, so basically creating another human, or if not in the biological sense, in a kind of abstract sense, a thing which can think as naturally as we do and can interact with the real world we have around us as naturally as we do. The other extreme, I think, is a much more abstract sense where we develop algorithms that can reason on their own, given some facts and a system of logic. So a system of logic which will govern how to deal with those facts. So I think, like, I'm by no means an expert in the subject, but this is how I like to view it. And I hope that this will kind of give a short background and context of, how you can view AI and the question of artificial intelligence in general. In the past, people have been thinking about this for a long time. As I said, we've had, so this on the left, you can see an ancient Greek coin depicting Talos, which was an artificial, massive, giant robot created to defend the cities of Greek. So these are stories in Greek mythology which tell of this automaton or an artificial human created as a soldier. More recently, or still kind of in the past, we have Shaky the robot from the 1970s from Stanford, which had through various sensors and various internal algorithms could navigate around rooms without bumping into people. It was I guess a great breakthrough for the time, or a great development for the time. And of course, I think most of you would know about IBM's Deep Blue, which beat Garry Kasparov in chess, which is the first machine to beat someone in chess, which I think, in the past, we've had these kind of major breakthroughs, and people have been pursuing this question of AI for a long time. More recently, developments include robotics, so robots which can learn to do complex tasks such as solve Rubik's cubes. The important point here is that the robot learned to do everything from scratch, and it wasn't programmed to do it, unlike robots like Shaky, for which everything was programmed and the robot didn't really learn. We have systems like autonomous driving, which everyone is really excited about, and which are building on technological developments as well as developments in AI, which allow us to perceive the world around us in a much more accurate way, and also to plan in that world in more efficiently and more robustly. And also, some of you might have heard about the breakthrough recently in protein folding from DeepMind, their model called AlphaFold, which is able to fold proteins in a much more efficient and faster way than, or maybe a correction to that is, it's able to fold proteins that even weren't challenges that weren't even able to solve by classical algorithms. So you can see it pervades not just these. We aren't just talking about robots here, but we're talking about systems that can think and plan as we do, and also can reason or think about highly abstract and complex things such as biology and proteins and very highly specialized fields, and not just general things. So I think there's a broad range of advances that we've had recently. Something a little closer to home that you might have experienced is the incredible, the recent advances in speech recognition. So there have been recent developments in deep learning which have allowed speech recognition to get much better and allow it to be used in smaller devices such as phones. And you can just and it's uncannily accurate, leading to solutions such as on-demand translation, voice search, voice control. We also, I think this is ubiquitous in today's world, is recommendation systems. You'll find recommendation systems built into shopping websites, media consumption websites, even your Google search or any search engine you use will use similar systems underneath to kind of give predictive results to you. Also, there have been recent advances in using learning-based methods to improve prediction for navigation and also prediction for wait times in solutions like Google Maps, which kind of give you a route and also predict the time it will take. And instead of relying just on simple estimations, we are now learning, or systems are now learning how to predict that those things better. But we haven't reached that that level of building something that is at the level of Talos that the Greeks had envisioned all those thousands of years ago. Here on the left, you can see a simple kind of a one-legged agent which is trying to walk, and it's learned to walk by backflipping, which is probably one of the most inefficient ways to do it, but that's how the learning, or maybe not inefficient, but one of the most unnatural ways to do it, but that's how the learning process is kind of guided it. In the middle, you can see various robots falling down, because while our AI systems can work very fast and efficiently, a lot of times the real world isn't the perfect world that we kind of a lot of times assume when developing these robots and algorithms. And the real world can be cruel, and you can see the robots kind of falling prey to that. And also, while there might have been advances in computer vision which allow us to detect what is a truck and what is the traffic light. If we have an autonomous system, I think many of you would have seen this, that if you have an autonomous system which detects, which has been trained to detect traffic lights and slow down when it sees traffic lights or stop when it sees traffic lights, how does it reason about very cases which it hasn't seen before, like traffic lights on a truck? So I think we still have a long way to go, and hopefully this session will, this symposium will give a broader context of where we are, especially in industry and the use of AI in industry and social development and internet businesses, these areas, and also how, if you're excited by ideas like these and challenges like these, how you can get started and how you can make the best decisions for yourself to get into careers that will allow you to tackle challenges like this. A quick word about who we are, the organizers. We are the Society for AI and Deep Learning, a group of students from BITSCO who are passionate and really interested in AI, machine learning, deep learning, and the question of intelligence in general. Our members work with a broad range of organizations across the world, from Mila, Harvard, University of Oxford, and a lot of other diverse and well-respected institutes. Our main aims are to make AI more accessible so that people can get into developing and tackling problems much easier, much faster, by having the resources they need and having the right guidance they need to get into the field. We want to inculcate the spirit of research and exploration, specifically in the field of AI, among the student community. We also organize a bunch of open source projects to help people get into the implementation aspect of things, research and implementation based challenges, so that they can have starting points to try to tackle and also learn what it's like to maybe do a research project, and also student run courses to deliver knowledge about new and exciting areas right to the students. Also, I'd like to acknowledge AppCare, which is the AI research laboratory, AI research group at BITSCO, and Professor Ashwin Srinivasan, who heads the AppCare, who we're organizing this symposium in association with. And this symposium wouldn't have been possible without support from AppCare. So that's the introductory session. I think might have taken a bit longer, but yeah, we'll take any questions for a couple of minutes now, and then we'll move on to Professor Ashwin's opening keynote. So if you have any questions on the logistics, any question on how we'll be conducting the event, or any other questions related to the event in general, now would be the time to ask. To sign up for the social, if you need to go through the registration form. As part of the registration form, there is a question: do you want to attend the social or not? Just tick yes, and there'll be a few more details you'll have to fill out. The registration link is on our website. Yep. So Ritesh, if you want to get an idea of the contents of the talks, I think you can check out the schedule on our websites. It will be much less technical and more on the general side, talking about trends and specific things that students can do to get started. And there will also definitely be technical aspects covered with regards to the specializations of each speaker. Freshers, everyone is open to apply to attend the social. Due to a cap on the number of people we can accommodate, we will have to screen applicants, but feel free to apply. I think Harshit is asking, are biocomputers and AI related? Definitely, I think AI is, since we're talking about creating intelligent things and devices, we will have to implement them on some hardware. Yes, definitely. Currently, a lot of this is being done on computer, so silicon hardware. There is a lot of research, I think, on neuromorphic computing and incorporating the biological aspects of things. So if there are no other general questions about the symposium, I think I'll end my session and we can move on to Professor Ashwin's keynote. All right.
Okay.
Thank you, everyone.
Okay, is Professor Ashwin over here? Okay. So I'll give a quick introduction about Professor Ashwin. So Professor Ashwin Srinivasan is a chair professor at Department of CSIS at Pitspilani, Goa campus. He's also a visiting professional fellow at the School of Computer Science at the University of New South Wales. Previously, he's held positions as professor at IIT Delhi, research staff member at IBM Research India, university lecturer in computation at University of Oxford. Professor Ashwin has been working in the field of machine learning and logic for more than 30 years and is in fact one of the most experienced and influential researchers in the field of his interest, which is inductive logical programming. Professor Ashwin also works in neurosymbolic learning and related areas. So here's Professor Ashwin.
Good, thank you. Let me try and see. I actually didn't want to present any slides, but I'm going to try and do something else, which is to try and share my screen. Let's see now. So welcome to all of you. Is it the case that anybody is able to ask questions directly using their mic, or is it the case that they have to type and somebody will read them out? I don't know the details. How is that to work?
We've asked them to use the chat for now. So, and if there are any questions,
okay.
I'll just read it out.
Okay, because I would have preferred the direct question approach, but anyway, whatever works. So welcome to all of you for this second edition of this symposium. We had a very successful one last year, as in case some of you are coming back, well, welcome back. So the symposium this year has a slightly different look and feel to the one last year. Last year we were focusing on the idea of research in AI. This year we wanted it to be much more student focused than last year. I mean, it wasn't the case that the last one wasn't student focused, but this one we wanted it to be focused on topics and areas which may be of immediate sort of use for students in their undergraduate years, probably from the third and fourth years onwards, but nowadays probably even the second year onwards. So the sort of things that what do I mean by that? What I mean is that basically, what should I be working on? Is AI going to be a good field to work in? Maybe 5 years from now. Now there are planes which go overhead above us in Goa. So here's one, and that happens. I have to stop, I'm afraid, and wait for it to go past. So, okay, it's not such a bad one. Seems to be less noisier than normal. Okay, so the symposium this year, as was last year, is a SAiDL AppCare effort. So SAiDL, as was pointed out, is this sort of indie AI group, which is there in it's Goa, and I only found out about them a few years ago that there was this group of students who had very, who were very, very passionate about AI, both applications and implementations, and in fact had all kinds of very strict criteria to get into their group, much more stricter than almost than getting into bits, it seemed. So we, and I found that many of those who were working with me and with some other faculty members on projects were actually part of this group. So it became a natural sort of collaboration between the AI Center when it started in 2020 and this group. Let me tell you a little bit about the AI Center, because that's what I intended to say. So you can find out much more details by just going to Google's web and typing AppCare, AppCair. Now, can you see my screen on this, or?
Yeah, it's visible.
Okay. So so this is AppCare, the website at least, and you can follow various links. So in fact, one of the special links that I'm very proud of anyway is this AI Hive. But before I get to that, let me tell you what AppCare stands for. So AppCare is actually an AI research center, not just incidentally at BITS Goa, but actually it's a BITS-wide research center. It spans all campuses. There are members in each of the campuses. So if you're at BITS, say Hyderabad or Dubai or Pilani, and you didn't know that there was AppCare on your campus, you should let me know, and I'll try to do something about that. There may not be SAiDL on your campus. Is there SAiDL on the campus, other campuses, or is it just
No, sir. At least
okay?
not yet.
SAiDL is just a Goa thing. Okay, but AppCare certainly is everywhere, in at least as far as BITS is concerned. It stands for this. This is the expansion, Anuradha and Prashant Palakurti Center for Artificial Intelligence Research, hence AppCare. This is from the names of a BITS alumni couple who have donated $1 million for setting up this center, and with a fairly open remit on what needs to be done in the center. The people involved, you can see by going to people. There are faculty on each campus, adjunct faculty, of whom you will hear from two. Yes, I think two today. Gautam Shroff and Sachindra Joshi are both adjunct faculty with AppCare. Last year, we had also some of our adjuncts, Manik Barma, Lavkesh, we were giving talks last year. So this is the pattern. Basically, we want you to interact with our adjuncts, who are typically from industry, some from academia as well, and then a whole bunch of students who've been involved on projects with us. So if you go there, you'll see some of these admittedly sort of frightening faces in some cases, some who've just gotten up, and some others who have photoshopped themselves, I think, and whole bunches of, but altogether, all extremely enthusiastic students, and ones whom we are very proud of, because most of them have ended up in very good places, either in industry or in academia. So there's a whole bunch of these people. Most of these are all, as far as I am aware, from Goa, but I'm sure there will be others who will join them from other campuses as well. Yes, the AI Hive, if you're interested in this sort of thing. So here's a kind of interesting sort of potted history of AI in a sort of, I don't know, 20, 30 hexagons. So this is that Talos that that was mentioned. That's in the book, well, and various coins there. It's a sort of well-known myth, but as far as I'm aware, first appeared in Jason and the Argonauts, or the Jason and the Argonauts was the film, but there's a book on Jason and the Argonauts. Just a minute. Third century BC, I think. Even before that, the late C from around 5th century BC in China talks about a walking automaton who does something, all sorts of things in a king's court. Aristotle, as you know, probably, for his contributions to logic, Panini for his contributions to formalizing natural language. So these are, interesting robots from Al-Jazari, who's sort of probably considered the father of robotics. Leonardo, of course, figures in all these lists, and Descartes, and so on. So there's a whole bunch of people. You could sort of follow them. Where is it going? Who knows? Here's Turing, as was mentioned, but also Claude Shannon. Even before that, the McCulloch and Pitts approach, which is really still somewhere at the heart of it, even in all parts of deep learning, is somehow fundamentally involved in that. So it's a long and interesting and a story which is not yet anywhere near completion as such. So where is it going? Who knows? I mean, I would like to think that it is going. Those of you who are who want to get into AI, I would very strongly recommend a serious course of binge watching Star Trek. I think this is something which actually drives AI like no other sort of science fiction series. So maybe we end up in somebody like Lieutenant Commander Data in the future, but who knows? This is the sort of interesting aspect of where things are. So without sort of holding things up any further, I'm happy to have you attending this seminar. Please try to make the most of it. I hope it is useful and interesting. Our goal, as I said, is to get students involved with and excited about and look forward to careers either in industry or in academia in artificial intelligence, which is not just deep learning. It is a lot of other areas which are very interesting in artificial intelligence, and hopefully some of that will come through. I mean, deep learning will be some technologies involved in it, but the application areas like Sachin will talk about conversational AI. He's the head of, or at least one head of, I don't know how many others there are, but he's an important figure in the Watson development at IBM, both worldwide, not just in India. So I hope you'll be able to sort of talk to him and learn a bit more. Gautam Shroff, I know very well. You will find that he's one of the remarkable sort of character in Indian artificial intelligence. Aditeshwar Seth works in many different aspects of AI for society, specifically with agriculture. There are a few others whose areas I'm less familiar with, and I'm looking forward to attending their talks and finding out a bit more about it. So I'll stop here, and if people have questions, I'll take it. If not, we'll we can sort of take a break before Gautam's talk, I suppose. But anybody, if anybody has any specific questions, I'm happy to take it. So
Yeah, I think there are a couple of questions.
okay.
So one of them being, where can we start learning AI and M topics?
Where can you? So the person who's asking, are you at a university already, or are you somewhere else? Where can you tell me a little bit about yourself so that I can answer that in some kind of meaningful way?
So I think David asked this question. Feel free to unmute yourself and answer. Give us a little intro about your background. Okay, I think
Okay.
since presumably a lot of our attendees are undergraduates.
Yeah. Well, undergrads, it would be hard to believe that there wouldn't be a fairly well-established sequence of AI-related subjects in your curriculum. If you're in computer science, if you're not in computer science, then and your university has a computer science department, then I'm sure you will be allowed to sit in or attend those lectures. If you can attend them in person, then obviously very good. If you can't attend them in person, then try to attend them online. If you can't have access to those courses, then of course there are so many, maybe thousands of courses in the end. But I have found the usual suspects do a very good job. Things like MIT courseware is very good. Some of the Coursera courses are very good. Of course, in Andrew Ng's courses on deep learning and deep learning specialization, machine learning have been very popular over the years. Jan LeCun, I think, has a very good course on deep learning. So there are many. Shai Ben David has an excellent course on theoretical machine learning. So there are many, many good options. There are thousands and thousands of options, but there are some very good options, and you can always find those, I'm sure, quite easily. So.
Great. So for another question, Professor Srinivasan asks, does AppCare offer any certificate or degree programs?
Not yet, no. We're considering that, but it is something which is on our mind. What we want to do is then do it in a kind of live teaching mode, live in the sense of still being online, I suppose. So we don't want it to be canned sort of instruction lectures. So that maybe we will be able to do something about that over this year, and maybe start next year if we can get enough faculty time to be spared from the departments for doing that. So we would like to do it, but we'd probably keep it quite focused just on machine learning type topics initially, and then expand that to computational neuroscience and scientific aspects of AI next. And that's our plan at the moment, but that'll probably come about only 2022, hopefully. So yeah, but it's on our mind. Yeah, but
okay, so as a follow-up to that question, another question is, does AppCare provide short-term summer or winter internships to non-BITSCOA students?
Non-BITSCOA students, I mean, for BITS students, I think there is a regular kind of internship process for summers. What you have to do for any student from any university for internship is that if you talk right directly to one of the people in the AppCare faculty profile whom you want to work with, and if they're interested in your sort of in working with you, and if they're an AppCare member, then we can try to organize some kind of internship. The difficulty at the moment, as all institutions are facing, is really how to deal with the whole COVID problem. And we're at the moment in the process of slowly reopening our campus. So remote internship is always going to be much easier than the on-campus internship, at least in the immediate future. Not because of for just purely because of COVID type reasons, I think. But at least as a first step, you should probably get in touch with the person or persons whom you want to work with, and see where it goes from there. Yeah. But there's certainly, summer internships are part of the general bits. It's allowed in bits in general, and it just depends whether you have somebody whom you want to work with and they want to work with you. So,
right. So I think there are a couple of more questions about how to get started in ML. So I think Ashwin sir already covered this in that we start taking courses at your university, or there are plenty of courses available by top researchers on YouTube. If I just may add to this, if you go to our website and check out the SAiDL assignment, there's a section for resources over there where we've compiled a list of resources which you could go through sequentially in order to get started from scratch. I think we could take one more question before Gautam starts session. So yeah, an interesting question is, can quantum machine learning dominate all other aspects of ML?
I don't know. I mean, possibly. My brief sort of dally with quantum machine learning at the moment was not very encouraging, but that doesn't mean anything. I mean, it's possible. There are sort of interesting different aspects of quantum machine learning that are coming out now, which are different to. So before, people were just sort of trying to re-implement machine learning algorithms on quantum machines. But I think there are some sort of quite different kinds of results that are coming out now on quantum computation that could have quite a big impact on machine learning. So in principle, the answer is yes. And certainly, it's an area which, along with, say, DNA computing and things like that, which will be one of the sort of ways in which we are going to be able to deal with the problem of having to do vast amounts of computation. I mean, seems to me unlikely that we will be able to, build the kinds of huge computers that huge conventional kind of computing ways of heating and cooling and things will stop us from doing that, I think. So yes, I think it's certainly worth working on. Yeah.
Okay. Yeah, I think that pretty much covers. Okay, there's just one more question.
Okay.
It says, is it really possible to transfer human intelligence to machines, or just an aspect of it?
Oh,
general question.
Well, so there are two, in my way of thinking, and which is influenced somewhat by that and that Turing paper that was pointed out, which in mind called computing machinery and intelligence. In my way of thinking, there are two aspects of AI: the scientific aspect and the engineering aspect. So the scientific aspect tries to use AI as a way of understanding hypotheses about intelligence, brains, and behavior. So these are scientific questions about, what is the nature of intelligence? Is it what is, how are brains structured? What constitutes certain kinds of behavior, behavioral patterns, and so on. And the engineering aspect of it is to use techniques developed in sort of applied mathematics and logic and statistics comes in applied math, to develop programs that will actually work in a better fashion in terms of being more adaptive and more data driven, and typically sort of in an assistive fashion, just like all engineering tends to build tools, and tools are meant to be perform some function and achieve some goals. So the engineering aspects of it will be to specify the functions and goals of these sort of automated machinery that are adaptive. Now, you'll notice that in none of this I've said anything at all about transferring human intelligence to machines. What will be important, I think, will be to perhaps be able to transfer what we know to machines as they. So if on the engineering side of things, to be able to build machinery that is actually effective, it would be even more effective, I think, if we can transfer the knowledge that we have about problems to machines as they build solutions. Otherwise, they would have to invent it for themselves, which in principle they can do, but in practice, I think it's found that it's difficult for them to do for a number of reasons, mainly sort of resource-bounded reasons and various other things related to that. But that is not so much transferring our intelligence, however we want to define that, but to transfer what we know to machines. So I would focus, if you're interested in human intelligence, I would focus on the scientific aspects of AI and see how you can use AI to understand human intelligence in the scientific sense. If you're interested in engineering, I would focus on building more effective machinery and see how human experience and prior knowledge can be used effectively to build more effective machinery. Does that answer what you wanted?
Yeah, I think it does. Yes, it does. Okay, so I think we're out of time for Professor Ashwin's session. Thanks a lot for joining, sir.
Thank you.
And okay, so Professor Dr. Gautam Shroff is here as well. So
hi, morning.
Hello, sir. Okay. Hi everyone, I'm Vedant and I'll be moderating this session with Dr. Gautam. So I'll just give a quick introduction about Dr. Gautam Shroff. And before we start, I'd just like to emphasize that, as was mentioned earlier, we hope this will be an interactive session. So if you have any questions, just type those in the chat and I could pass them to Gautam sir. Okay. So Dr. Gautam Shroff is the Senior Vice President of Tata Consultancy Services and heads its research division, also known as TCS Research. He's also an adjunct faculty at AppCare and works closely with Professor Ashwin and has mentored a lot of students at BITS and SAiDL, including me. He has previously held faculty positions at Caltech and IIT Delhi, and has authored over 100 research papers in fields ranging from software engineering and machine learning. Within artificial intelligence, his research interest ranges from neurosymbolic learning to applied ML topics such as demand forecasting and time series analysis in general. Personally, I worked on a project with Gautam sir, and also took a course that he was involved in teaching, and I've got to learn a lot of things from him. And he's someone who has a lot of breadth in terms of knowledge in different fields, which is truly amazing, given that these days people tend to focus their work on one or a few subdomains in a particular area. So again, thanks for joining and taking time out of your busy schedule. Sure. Right. So to start with, again, I'd like to reiterate that if you have any questions, that put those in the chat, and I can ask Gautam sir. I have a few questions which we can start with. So one of them being, so over the last decade, there have been several transformative developments in AI in terms of its applications, such as especially in computer vision and sequence processing. So, all of a sudden we've seen a lot of practical applications. For example, due to advance in computer vision, we have applications like object detection and self-driving cars. Due to advance in natural language processing, we have applications such as chatbots. So where do you think AI will have the biggest impact in the coming decade? And what kind of new applications will these developments give rise to?
Well, okay. I mean, firstly, I think AI has already had a huge impact, as you all know. I mean, all the recommendations you get online, whether it's for e-commerce, advertisement, or whatever, even news, and is all AI driven. So I think your intention, your social media, everything is being driven by algorithms which involve some form of AI techniques. And I think there are good things and bad things about that. So all that is already happening. Now, what you mentioned about vision, certainly there are many applications of vision now getting deployed. But going forward, I think there are two areas I think we need to think about. If you think about the large industries, right? Then I think the way we look at it is there's an integration of what is traditionally IT, which is basically building systems which allow you to do workflows of various kinds, whether it is buying goods or selling something or applying for a loan or whatever, with an AI system or AI techniques which allow for intelligent automation of those workflows. Now, the intelligent automation could be now basically doing things which are repetitive again and again, and doing them automatically, so saving people's time, or sometimes allowing the same person to do many more things in the same amount of time, or doing things better. So, for example, if you have to order stock from the supplier, right, continuously, and you have to make those decisions based on the orders that are coming in, you could make them more intelligently if you had, suppose, a reinforcement learning system which figured out what was the best thing to order when, based on what it expected orders are going to come in the future. So, I mean, these are the areas where you can see those deployments, right? So, in real life, in sort of large organizations. But I think so. That's on the large organization side. And then again, on the what was going to impact people every day. I'm looking many years in the future, perhaps, but I think it's time that we are going to see robots. So, I mean, this pandemic, I've already seen many of my colleagues have actually bought robots to clean their homes. And I know somebody who heads a robotics group, he himself bought that machine, right? Right. So it's already happening. I mean, this is Rodney Books, the company from 2000, and they built the iRobot thing, and there are many clones of that. There'll be more such things. Now, yesterday, a few days ago, I think Amazon announced the some robot for the home. It just drives around and talks to you and looks around and does various things. So it's getting there. Now, how fast it's going to get there, we don't know. But when it's coming into everyday lives, I think the fact that this has come in and that market is actually seeing growth in a country like India, where there is already a significant amount of labor available, and there's much more globally. So there are 30 million of those sort of cleaners deployed worldwide. That's a large number. And I think I think the future belongs there for the everyday life. I mean, the online world will remain, all your targeting and all that stuff. Large companies will do a lot of automation and optimization, and the consumer will see physical automation.
Right. So I think robotic automation is an interesting area where AI could definitely make advances in the next few years, and we've already seen. But still, the fact remains that a lot of robotics applications are still operating on classical algorithms. Now, if something like AI were to make its mark in the robotics field, again, which we're starting to see it happen gradually, what would it take to deploy such AI applications on scale? And not just robotics, but as in when AI sort of starts taking over different areas or different industries, you need to scale your approaches or adapt some newer measures to deploy that AI for mass production or deploy that AI scale, basically. So what are some of the transformations that you think are required in the current industry to sort of adapt to that as quickly as possible and as efficiently as possible?
So I sort of like to classify deployments in three categories. One is the sort of the nice to have, and failure doesn't cost you too much. For example, if the wrong ad gets targeted, nobody dies, right? Maybe the ad exchange makes it a little bit less fun, right? So error is tolerable, and then you can continuously optimize it in a very automated way using reinforcement learning and things like that, right? Or a chatbot. If you give the wrong answer, humans typically know it's wrong, or they'll figure out it's wrong and they maybe complain or put a thumbs down, and then you'll have to deploy some system of people which looks at these responses and fixes the training data so that the next version of the system has the right answer. So those are the let's call it the desirable ones, but they're not mission critical, right? The second category, that's I think the low hanging fruit. Everybody can, I think that's easy to deploy because in some sense current AI techniques, machine learning techniques are very well suited to that. They make mistakes and you have to fix them by retuning and getting more labels. You just keep doing it, right? You have to deploy people to do that, and it keeps happening, right? The second category is where you're actually trying to save work, right? Say you're going to take a whole bunch of documents and automatically transcribe them, right? Or you're going to translate them, or you're going to convert them into one form or the other. And now, if you have an algorithm which makes, for example, 90 or 80% accuracy, well, trouble is you don't know which 20% is being mixed, right? So how much checking do you need to have to do? And most of these MLDL techniques and all, they are not calibrated properly, so they often give you huge confidences when they're actually wrong. And those huge, so firstly you need calibration, and second you need high degree of confidence. So what's better, a system which does 80% accuracy, but you don't really know that it's very confident most of the time. It's not too confident, right? Or you want something which is sort of 90% confident or 99% confident 30% of the time, and it's calibrated. So 70% of the time you'll put a human to verify the output, but 30% you just close your eyes. The 30% you've actually got a gain, and you can actually bet on. In real life deployments, this is a problem. If you don't have the right balance between calibration and the percentage of time you're confident, you can't deploy it. You get stuck, right? Because you have to keep having people check it. So that is one area which probably is less studied than it should be. And I think we'll make some progress. So that's one scaling issue. Correctness, right? And the third is the case where it's mission critical, right? It's not there to save work. So in the case of confidence, you really want a large proportion of cases which 30% of the cases have 99% confidence. But suppose you have a mission critical, you're operating a nuclear power plant, right? And there has to be a human in the loop, right? And so even if you're 99% confident 30% of the time, the rest of the time human makes decision, even when you're 99% confident, human will not take that decision without an explanation. So unless there's an explanation which assists the human, you're not going to get a deployment. So I think, so that's first is the easy one, where you can apply sort of less mission critical, desirable activities. Second is, save work. Then you need, some guarantees on how much work you can actually save while close your eyes and do it. And the third is, even if you can do that, then you have an explanation. If it's mission critical, the power plant might blow up or something, right? So you have to be very clear. So those two areas, I think, need a lot of work.
Right. So about, I think, especially about the second point, I think that present day approaches aren't properly calibrated. So there needs to be some or the other human intervention, I think. So in that sense, it's probably better to just, think of AI as something that helps humans rather than just completely eliminating the need of human intervention for any particular process.
Yeah, but automation has always been there. I mean, all computing is all about automation. I mean, from the when you started talking about doing data processing, it was all about automation. It always has been in all factories, and anything that you did from industrial revolution is all about automation. So automation is a core element of technological advancement, and that you can't throw away. So if you can't do it right, and even today, you can't do it right to actually save work in blind tasks, right? Yes, you can save work. For example, if you have a chatbot, you're taking the load off of human call center by having a chatbot. Yes, you can save a lot of work because a lot of humans start getting service. But the human is always involved, at least the recipient of the communication is involved. So if he has a problem, you can always call up somebody. Right? But if you're just processing documents, which might be invoices, suddenly the wrong guy gets paid, you have a problem. Okay.
Mm-hmm. That makes a lot of sense. Okay, so moving on to a slightly different topic, a slightly different question. So since you're someone who is involved in both academic research and research on the applied side, so we see a lot of quote unquote blue skies research in AI, which is born out of curiosity and which doesn't really have immediate industrial applications or immediate isn't deployable right after discovering something. And this is true specifically for fields like reinforcement learning. And often, so if we talk about the research output that comes in these fields, often the results are they're demonstrated as performances on toy environments. But this obviously, as I said, isn't immediately deployable. So there's like this huge gap between, this is not true for all fields in ML, but there's, I think, at least some gap, which is particularly huge for some fields between research and deployable solutions, both in terms of the time it takes for some research to get converted into actual application oriented and stuff, and also the engineering effort that it takes. So as someone who has a lot of people working under them, who has a lot of employees working under you, what kind of jobs are present at the intersection of these two things? So what kind of skills would be required for someone who wants to work on converting research to actual deployable solutions?
Lots of questions. So let me answer one by one. So first of all, you took an example of reinforcement learning where Atari games was the sort of the first wow moment and then, chess and go and all that, right? Checkers was solved in the 90s. I don't know if you know that, but there was a program which solved checkers in the 90s. Could beat a human, right? So this has been a continuous evolution of games. It was not a real reinforcement learning solution. Neither was Deep Blue, which beat the chess Gary Kasparov,
Gary
right?
Kasparov.
But then now there's Go, which required some deep learning and stuff. But if you look at the whole, so you took reinforcement learning as an example because the Atari game thing that appeared very playful. But I just gave you an example. If you're trying to order some new stock in a warehouse and you have orders coming in a distribution center and you have to order from the manufacturer, when do you place the order for what? Because there's always a time lag, there's a gap, there's uncertain orders in the future, and there's uncertain supply from different suppliers, right? Now this is a game. Human operator sitting in front of his terminal is playing that game. He wants to make sure that there's not too much inventory being built up. He wants to make sure no order gets unfulfilled, and he wants to minimize delays. So it's a game, and there's a score. You can think of a score being played. If you speed the game up, you can actually make it a video game.
Right.
Now you can train a reinforcement learning agent to play that game and then deploy. And actually, we're doing that in supply chain. Same thing is getting done if you're thinking about placing, giving offers to people coming in on a website, and you have a budget and you have a certain number of buys that you want to get. It's a game. You're trying to choose what to put in front of the guy, and the guy will certainly go ahead and buy or not. And then you, or if you're doing something in the financial market, where of course it's a much more difficult situation because the system is chaotic, but still it's a game. So games are real. I mean, most of human activity can be viewed as a game. And there's a famous term called homo ludens, right? Most of human work, what we do in a society is like a game. We keep ourselves busy, right? Unlike the animals who just go out and try to find food to eat and then go to sleep, humans keep themselves busy with other things like philosophy and mathematics, which are all games, right? So games are important. That's one. Now the other question you talked about was what kind of things someone coming into industry should look for. I really think that you have to do both, right? So I think academic research essentially is either there's a why question, which is science. Why is the world the way it is, right? You just try to understand the world. And then there's the engineering side of academia, which is why can't the world be a little bit different? And can I do something differently, right? So that's the foundational research there. So that actually has to happen largely in academia. But if the industry doesn't do some of that, it will be very difficult for you to figure out what's going on at the cutting edge of academia. Industry can then essentially do two types of work, one is applied work, because you're asking a question, there's a problem in the field, and you want to do just to sort of solve that problem, and you try to rely on the foundational activities like reinforcement learning. So instead of solving optimization problems which take hours to solve, you train an agent which just knows what to do, because it's so there's a fundamental paradigm shift which is possible because you have access to the foundational work. If you only knew how to apply linear programming, then that's all you know. You wouldn't know what's happening in the whole scientific world. That new things are coming up, and you could possibly try something new. So you need to have that connect, right? And then there's translation work. So you do all this stuff in which is in the foundational area, and you have to now transfer it to production. And make it into a system or a product, right? So industry needs to do both. Now, not every industry can afford to do both. So those industries that can't afford will tie up with academia more strongly to do it, right? Or wait for somebody else to do it and buy their product and use it, right? So I think when you get into industrial work, as I think I got the last piece of Ashwin's conversation, that if you're interested in the why only, then you belong in academia. If you're interested in the why not, then there's a place in the right industrial organizations for you, because you're always trying to make an impact, trying to do something a bit different, right? Trying to make a change to where maybe anything is, maybe a new type of battery, a new type of chemical or whatever, right?
Right. Okay. So yeah, I think so at the current stage in AI, there's no way that industry could get rid of research in general, unlike other computer science applications such as software engineering. Someone could be just employed involved in software engineering but not really be doing research in that area. But that's probably not true for artificial intelligence or even deep learning.
I'm not sure because you see, that may have been true maybe 10 years ago for say a e-commerce company like Amazon. The recommendation systems they were building on Netflix or whatever, right? They required scientists to build it. Right? But today the field has become many of the very good algorithms, the good techniques are now commodity. You can just pick up the implementations which are now open source and just use them, or you can go to a cloud provider and you have enough documentation to build a recommendation engine, for example, or something else, and as an engineer without doing this time. So in some sense, it's not true that you need to have research to deploy AI anymore. You don't. What you will miss is the new things which are happening before they get translated into the open source implementations, which just do things without your having to invent. You'll miss being at the cutting edge. That's all. You'll be at the lagging edge. You'll do exactly what everybody else is doing. I mean, if I can build a recommendation system using a SageMaker on Amazon, so can you. Right? It's a skill.
Right. Mm-hmm. Okay. So another question I had was, so if you look at a broader picture in AI, there seem to be two broader directions in which the community is divided, or not divided, but the community seems to be working. One being the data-centric approach, wherein the focus is on collecting large amounts of data and ensuring that the data that we train our models on is of good quality, has well balanced in terms of number of classes present, etc. And the other being just to develop better machine learning or AI models or learning paradigms. For example, meta learning, which do well even when trained on chaotic data or noisy data or just data of poor quality in general. So what do you think? What, in your opinion, is the correct route going forward? Because theoretically, at least the way AI is envisioned, at least in pop culture, let's not bring pop culture, but it's theoretically we expect that an artificial general intelligence, or the goal of artificial intelligence, would be achieved when the models are able to sort of perform well, irrespective of the type of data that it's fed. So what do you think is the way forward?
Well, I don't know. See, you're confusing artificial AI with ML.
Right. Okay.
So AI doesn't need to have ML. I mean, AI in its own form was, even if you're searching for a solution without any past data, heuristic-based search is still AI. Right? So it's an AI technique. If the field has a search set of techniques, and machine learning is just one of them, and deep learning is one rather popular and very successful way of doing things. But I mean, historically, it has evolved. There are many different ways of doing the same thing, right? So I think that the learning from data is one important part of AI, but it's not AI. Right? Okay. So that's one thing. The second thing is it's also important to understand that where we are today, I think I would rephrase your question a little bit. The two schools of thought, in my view, are the path that we are on is a linear path, and if we keep going down this path of putting more data, having better architectures, and keep training and keep more and more machines, in the thousands to the tens of thousands, hundreds of thousands, millions of machines that are doing all this, somehow what will emerge through some mechanism, it will surprise us beyond our imaginations, and we will ascribe a stamp of artificial general intelligence to that. That's one view, right? Whether you train it using RL, you train it, whatever. Right? A lot of people have taken that view. The other view is that we are still missing something very critical over here, and we need to essentially it's not just throwing data at the architectures. The architectures themselves have to have an inductive bias, which is perhaps derived from a deeper understanding of how brains work, how neurons work, or even from some other source. And we need to, there's enough scope for doing new things in that direction, because we are missing, and this first path will not lead to some miraculous AGI, as you mentioned it. So I would call it those two schools of thought are there, right? And I would put myself in the second school. I don't personally believe that this path, linear path, is going to get you. It's already plateauing out, right? And the benefits you're getting, if you look at the large language models, right? The benefit, yes, the benefit you're getting by 175 billion or maybe a trillion now, which is in China, or more. I mean, there is a benefit from 175 million to 175 billion, right? But is that an engineering benefit that yes, it looks and feels better, or is it a qualitative benefit? That I don't think we've got it, right? That is it.
Right.
Is it suddenly that something new has emerged by going 1,000 times more? That suddenly there's actually some reasoning emerging or something. I don't see that yet. So that's why I suspect that this line may plateau, and you will need a different type of some new ideas, new breakthroughs. And the thing about is that in those cases, you can still do some work without having access to a million machines.
Right.
Like things like causality, things like disentanglement, and things you can do fundamental theoretical or experimental work on small scale problems which actually make advances. I think that's probably if you're in the second camp, that's where you will put your money, right, or your time, right?
Mm-hmm.
In the first camp, you will get out of any organization, you will run towards people who have millions of machines, otherwise you will not be able to do anything, right? Because you believe that that's the only way.
Right. Yeah. So first of all, thanks for pointing out my mistake. I think this is a very important misconception to clear that AI, ML, and DL are separate. So machine learning and deep learning are just subsets of AI. But if we talk about practices that are majorly used in these large organizations, a lot of them seem to focus on machine learning and deep learning. And so if we talk about organizations like Amazon or Google, the primary motive of these organizations seems to be data centric, to just collect as much data as possible and then train a model or train any kind of algorithm to perform well. Whereas so first question being, why do you think they're following a data centric approach? Is it just because investing or following a data centric approach just gives more immediate returns as opposed to investing in long-term research?
Well, firstly, for Google, Facebook, AI, and Twitter, I think they're all in the first category of applications where they're not mission critical. At most, you may lose a bit of money, but there are humans involved, and you might not make as much money. There's a competition at that level, but it's not mission critical in the sense that somebody will die.
Right.
So the area which is the most interesting in this is self-driving cars. There, it is really a question whether you would ever sit in a self-driving car which is trained and runs end-to-end only on data-centric. I would certainly not fly in such a plane. Okay, I might sit in such a car on a highway in the United States, but not even in New York, or certainly not in Delhi. And I don't think we are going to get to a self-driving car which can drive in Delhi with this part. That's my belief. Right. But I may be wrong. If I think you need something else, and I think you need to actually have an engineered solution which has a multiple sets of models or algorithms running and checking and balancing each other like a plane. I mean, every system is like 10 redundant systems to make sure the plane still flies. The plane is an autopilot. Okay, once the plane takes off, the pilot can just go to sleep, and even while landing, in say Heathrow runway 6, it will land Heathrow runway 6, no problem, because you've got engineered systems. Self-driving cars, in my view, will have to move towards an engineered system where you have corridors, you have areas where there are only self-driving cars, and then it'll work just like planes work, right? Okay, but if you're going to have cows and humans, and even in New York, cab drivers, I mean, I don't think you're going to get there with this way of. You may get there, but I don't think you're going to get there with this line of attack.
Right.
Okay. That's where it's mission critical. Yeah.
Right. So yeah, it all depends on the task at hand. Okay.
So there are a lot of questions coming in, I guess. Yeah. Anyway, go ahead. Yeah.
Right. So I was thinking we could take these questions after, let's say, 10 minutes or something.
Okay. Yeah.
Right. So another thing being, okay, slightly again deviating a bit to a slightly different question, but so even though we have these large language models like, let's say, GPT-3 or Codex from OpenAI, and a lot of people consider these to be as stepping stones for AGI. The fact still remains that classical symbolic approaches still have advantages in some areas, for example, in terms of generalization or in terms of reasoning. So, and there are a lot of advocates of a purely deep learning approach to artificial intelligence. So what are your opinions on this? Do you think symbolic approaches or other classical approaches still have a role to play in this, or deep learning should suffice moving ahead?
I certainly think that if you're going to have solving engineering problems, you're going to solve a problem and you want to make sure it works, then you must use a combination of these techniques, and the symbolic techniques that certainly have an important role to play from an engineering perspective, right? Like Ashwin also mentioned towards the end, I mean, if you're going to solve a problem, use whatever, you don't be religious about it, right? And there are certain advantages to taking advantage of whatever you know about the problem to solve it, right? Now, when it comes to the more scientific question, right, on where do symbols actually come from? I mean, how the hell do symbols come when all we have is neurons, right? Right. That's the scientific question, right? So there are many different thoughts. I mean, there are some maverick thoughts. Like, I don't know if you guys have read this recent book by Jeff Hawkins, the Thousand Brains Theory. Very interesting book. I mean, he's a crazy guy. He founded PayPal, and then he set up his own. He became a billionaire and set up his own research institute, and he's been doing this crazy research, which is totally at odds with what the rest of the community is doing. But he's learned a lot of neuroscience in the process. So what the book tells you is a lot of neuroscience ideas which are relevant to the way you architect things. I don't think he's got it right. I think he's hand waving much more than he should be. But there's something there. So I mean, then there's if you look at another book I read called The Spike, right? which is about trailing one spike as it goes from your eye to your motor, neuromotor cortex, right? Where you can control your hand, right? What actually happens in that entire thing? It's not clear where does the symbol come from, right? So there is other experiments which tell us that if you take a rat and you put electrodes right on some part in what are called grid cells, right? And as the rat moves around, the grid cell lights up every 3 inches in a box. There's one cell which lights up 3 inches x coordinate, other cell which lights up every 3 inches y coordinate. Why? Then there are place cells which light up only when the rat is in one position. So it tells you that somehow the symbol, the position has arrived, has somehow been sort of learned. So symbols have arisen. Now, how far you take this, and it's happening in an unsupervised way. And nobody told it that this neuron, please be a XY coordinate for this guy. I mean, to light up only when this. So this is why I think that some of the work in disentangled representations is very interesting, right? How do you learn representations where the features actually mean something without your telling the system what you want it to mean? So stuff like beta VAE, VAE, and those things are really, I think, very promising approaches, right? And I think we'll get there. I mean, but there's a lot to be learned, right, over there still. So I think architectures will get there, right? But it will take. It won't be just by throwing computers at the problem alone. Do something different, something scientific.
Right. So
yeah.
I guess symbolic AI is sort of this abstract representation of intelligence, and deep learning is more like a lower level representation, and there's a need to map deep learning to that higher aspect of intelligence. Okay. So okay, I have a couple of questions that I just wanted to ask. So this is from the point of view of any undergrad who would like to get started or would like to explore career options in the field. So as someone, so I know TCS takes in a lot of research interns in the field of or AI in general. So what kind of skills do you look while hiring someone, or what kind of skills do you want in the next generation of engineers who are working in this area?
Well, you asked very different questions. So engineering-wise, I think it's clear. I mean, you need to be a good engineer, right? You have to be able to program well, do good software engineering. You have to be able to use open source tools. You have to be able to understand what are your techniques, how to use them, how to use the libraries, and you know all that thing. I mean, that's engineering. So that's an engineering hire. Right. So we are actually hiring this year research engineer also, and not just researchers, right? So research engineers will be of that category. Perhaps as for AI, for something else, it will be for another field. It will have another set of skills, right? For security, you'll need to know about intrusion detection system. You need to know about cryptography or something, right? But as a practitioner, if you want to go into research, it's a bit of a different mindset, right? The ability to be given a problem and then think through it from first principles as to how you might want to solve it. And if in the process and you actually rediscover ideas which you should have learned from a book, that's great. I don't mind if you don't know it from a book, but if the way of thinking was systematic and perseverant, that you don't give up when given a problem to solve.
Right.
You keep at it and make reasonable. So somebody who says I don't know in an interview is not going to be a good researcher. Somebody says, I don't know, but I think we could do it this way because X, Y, Z. And you reason it, you try to solve the problem. I don't know means that, I don't know. It's in the, I couldn't, it's not in the, out of syllabus for me. I didn't study for it. So then I don't think you'll be a good researcher. You might end up being a good practitioner because then you'll know you'll go read the book and do it. The researcher will say, I'll try to figure it out myself. And then he might beat himself on the head and say, look, I should have actually just read the book because I wasted, 10 days reinventing something where it was already available, right?
Right.
So, but that's still that you didn't waste 10 days. You actually, your mind got trained in the process.
Okay. Yep.
So I think that is important, right?
Yeah, I think, that sums everything up pretty nicely. The last question I had was sort of a meta question about research in India in general. So I think there has been some survey, or I think this was the conclusion of Ashwin sir's keynote last symposium, if I'm not wrong, that India has a lot of talented people who sort of want to work in this field and are working in this field. But the kind of research that you see coming out of India is basically a lot of papers, but most of them being low impact and not contributing to the general advancement in the field. While some of them are obviously excellent, but this is true for a lot of research coming out of India. So why do you think that is, and what do you think should be the steps that should be taken in order to improve this at undergraduate level, or basically at student level, so that we can produce more impactful researchers?
Well, I don't know. There is a survey which came out last this January, right?
Okay.
21 or end of 2020. Stanford report on AI. Every year it comes on. And I also spoke about it recently that if you look at the number of people skilled in AI or ML or related techniques, that's the Stanford report, not my numbers or something. We are 3 times the country-wise average internationally.
Okay.
3x. If you take the average number of people per population, right, per capita, we are 3x, even per capita, right, which is surprising, right? But if you look at the number of papers coming out, we are way below number of publications coming out, and that's what you understand. And I think that's a sign of the size of research investment in India. That's one. And the second is infrastructure. So, we have not enough people working on not enough people working in the field, good people, and we have not enough infrastructure. Like I said, in spite of the fact that yes, the certain kind of work you can't do without a million machines, but if you don't have any machines, you can't do any. Right. So you need more infrastructure, and I think there's a national mission on AI, which I think 2 or 3 years ago it was promised in the budget, which had to have a large infrastructure, etc. But you know how it is. It may take some time before those things actually materialize. Things move slowly. That's another thing. So we need to invest, right? And the third reason is that the new economy companies, right, in India, whether it is the e-commerce companies or the social media companies coming up in India, or the sort of ride-sharing companies, they're not yet doing enough research. Once they start, right, I think it'll take off, hopefully, right? And we're lagging behind a bit there, but I think it'll take these things to make it happen. Right?
Okay, yeah. Okay, I think we could take some questions from the audience. So one of the question was, unlike large software service-oriented companies, why hasn't AI consultancy seen a huge growth in India, even after having so much budding talent for the same?
I don't know what is AI consultancy actually. So because I think it's just it's another facet of information technology. Right? So it's a new set of techniques and set of possibilities which now you can do. So it's in some sense it's happening even within the normal services business. I mean, I don't see any major innovative deal today, even the ones that we execute, which doesn't have an element of AI/ML in it, right? So it's going to be there. I mean, it's definitely there. I mean, people are taking computer vision as a given. I mean, if you don't deploy it in something, even if you are doing a rental car return, if you don't have some kind of vision-based system which is going to give you a heads up on, in addition to the human check, you haven't done your job, right? So you have to just do it, right? It's getting done left, right, and center. So it's already happening. I don't think AI consulting is a separate field.
Okay. And a follow-up question to that is, what advice would you have for young talent in AI out there for starting up a business in India for the same? So I think what the person means is there's a lot of scope for applying AI in business specifically, but not a lot of work has been done in this aspect. So how could one go about making the right choices in terms of not missing out any critical applications of AI?
See, firstly, I know where this question is coming from, but that the danger is to confuse the technology with the desire to do a startup. Right? The startup is not about technology; it's about solving a problem. If you figure out a problem that has to be solved and there's a need in the market, you solve it with or without AI. Right? So if you get hung up that I will only do it if it uses X technique or Y technique, you might not get anywhere. The key is the problem. So I think when you have to identify a need, and you want to solve that problem and not worry about how it's done.
Okay.
Right. So that's probably the issue. Right. All the successful stuff people have, they got started because they focused on the actual problem that they're trying to solve, right, and not the technique that they want to use.
Right. So I guess there's no point in pushing AI where other approaches.
Well, you might use it. It's good to have that tool under your belt.
Right.
But I think they are orthogonal questions. Right. Right.
Okay. Yep. Okay, I think this is a bit on the technical side. So how can we transfer the non-reward aspects of humans into machines, such as motivation, intention, emotions, etc., with respect to reinforcement?
I don't know. That's a big question. It's a very important question. And I think there are a lot of debates as to where they actually come from, right? So in some sense, if there is no external motivation whatsoever, right? Why would a robot do anything? Right? Why isn't just try to do nothing? Right? So or just go to sleep or whatever. I mean, there has to be some external driver, right? So if there's in any system, if there's no, I mean, Newton's law, right? If there's no external force, it will not change its motion, right? So there has to be something. So where that comes from in biology, I mean, I think as far as everyone so far thinks, it's basically homeostasis. You're basically trying to maintain the system, right, and improve it, right, at a core level. that improvement is fundamentally is to do with survival and reproduction. That's Darwin, right? So now how that has evolved beyond that, it's a very difficult question. We don't know the why of things as much as what actually happens. So I don't have the answer to that question. It's a deep question.
Right. So another question being, what would you prefer should a student of AI or student in AI, I think, should, okay, I think, okay, yeah, so I think I understand it now correctly. So what would you prefer a student in AI should do in terms of research? Is it better to develop new things, try out ideas of their own, or to build on work of others to solve problems?
Yeah, I think it's easiest to build on work of others to get a reputation. I think if you're starting out, it's important to learn how to do incremental work and get it accepted. Right? But there are two sides to that. One is you might not succeed, in which case you might not want to do it. Second is you do succeed. And then the pressure to do more of the same incremental work is there because you got one and you can do another one. And then at some point you might want to say, look, I've done enough of this. I don't want to do more of this. I want to do something different. Then you have to take a leap of faith and say, yes, I will try something different. And then maybe maybe go and talk to people who are doing different things, learn something new. In my case, you say, I'll teach a new course, right? I'll teach something which I want to learn, right? So you get into that, right? And then you hopefully be able to change. So I think it's a matter of what you do. So you can, I think for someone starting out, understanding how to do the incremental work is very important. Right, to be able to read papers and figure out gaps and say, how can I fill this gap and get published? Right, otherwise you don't build up the confidence. But there's a self-fulfilling danger to that's all you end up doing.
Right. So
and that's what I see. I mean, when you look at the PhDs coming out, some of them I see are on that path of just cranking the sort of turning the crank, right?
Yeah.
And I'd like to see somebody who has a little bit more passion, vision, desire to solve something and say, I'm doing this, but actually I want to do that. Right. That's right. Right. Yeah.
Okay. Okay, so this question is related to something we just discussed about data-centric and model-centric.
There's a whole bunch of things on my chat which aren't you seeing?
Yeah.
I don't know, there's a whole bunch of things which you seem to be asking from a different chat, is it?
Right. So we're filtering the questions.
Okay, fine.
According to our relevant.
Okay.
Yeah. So this question was related to what we just discussed about data-centric and model-centric approach, and the calibration thing basically. So the question is the issue of calibrating neural networks more data-related or more model-related? How can it be fixed?
Oh, look, there are lots of techniques for calibrating the network. And I think that it's become a crowded area now, and you can always try to improve it. There are dozens of such techniques. What's missing is a very technical thing, what I mentioned, and how do you make sure that you actually get high confidence predictions for a significant fraction of your data. It's data related, definitely. If your data is bad or is different from your test training and test is bad, you have a problem. Can you predict it? So those are things which are open today. It is very much data related. Right? Mm-hmm. But given the data, you see the data, you don't see the prediction, but can you tell something about just looking at the data? And that's where unsupervised models and representation and stuff become.
Mm-hmm. Right. Okay, so I think we could take some more questions before the next session. So one of them being, And I think a lot of people would have this question that ML is a very rapidly evolving field, so you sort of need to keep up with research. So what are the best practices to keep up with recent developments? Yeah, I think that's the question.
Yeah, I mean, I do a lot of different things, right? For example, Twitter. Follow the right people, and you get to know the right people. Papers, right? Second, look at the feeds which coming in. You'll have, every day you'll have probably a minimum 5 probably interesting papers to read out of the maybe 10 that you 20 that you see every day, because of your feed, whether it is Twitter or wherever you're getting the feed from, or just Google archives, subscriptions, or whatever. Look at the titles. One which looks slightly interesting, read the abstract, and develop the ability to basically figure out what's in that paper without reading it, and decide which one you actually want to read.
Okay.
Because otherwise you'll get overwhelmed. Right? It is not possible to keep track with everything. So typically, if Jan LeCun is tweeting something, it's probably more worth reading than something that you just found on archive. Right? Not always, but you're following someone who you think has a good eye, so you read what he thinks is good. Right? Simple.
Yeah.
There's a bit of bias here that you will get drawn toward things which Facebook does or whatever. But I mean, that's the way it is, right? Ultimately, those papers are the ones which are going to probably be better than the random one, because the random one will take you a lot of time to figure out that it's not really important, right? But it's a tough one. I mean, you have to build an intuition for what to read and what not to read, and how much depth to read it in. Right, and figure out that you understand how this works, but you won't understand it in too much detail until you actually have to use it.
Right. Okay, so I think some people PM'd you the question, due to which we can't sort of see them. So if you see any such question and spot a
No, I don't have any personal questions there.
Okay.
No.
So in that sense, I think we've covered. Okay, there's one more. There's one last one. That, where do you see the use of genetic algorithms to be more prominent in future?
Well, you see, we did this even with Ashwin a few years back. 5 or 6 years back, we published a paper where, what is genetic algorithm? Right, it's an optimization algorithm. You have a population, you look at the good fit and the bad fit, and then you draw again from the good fit, and then now the question is, what can you learn about the distribution of the data, good data versus bad data? Can you build a classifier which says this is good and this is bad, or a generative model which says this is good and this is bad? Instead of using things like the crossovers and things, can you use more statistical approach? And say now that's called EDA algorithm, evolution of distribution algorithm. So can you use a generative model which will now generate more good guys? So we did some of this 5 years ago, and this came out. So including ML into genetic, that's an important area of optimization, and that people have worked in.
Right. Okay. So I think that sort of covers all the relevant questions that we had. Yeah, I think that's it. So thanks a lot for joining, Gautam. So thanks for taking time out of your schedule, and it was really great to have you.
Very good. All the best.
Thank you.
Bye.
Hello.
Hello, sir. Okay, so yeah.
So hey everyone. I'm Somesh, and I'm a core member of the Society for AI and Deep Learning. I'm so pleased to be with you today with AppCare AI Symposium 2021, and to have the chance to introduce our guest speaker, Sachindra Joshi. He's a senior technical staff member and manager at IBM Research. He's currently leading the research efforts in building multimodal conversational systems. His interests include dialogue systems, text processing, NLP, and he's a true standout in his field. So he has a great understanding of conversational AI and a great appreciation of what it takes to build computing systems that can interact with humans in a natural manner. Besides that, he has over 2,500 citations, a 25 plus H index, and over 50 patents granted and filed. So I hope we are in for a treat today. Without further ado, please join me in welcome Sachindra.
Thanks a lot, Somesh, for kind words. I'm very happy to be here, and would be really glad to kind of talk about conversational AI, what it is, what are its prospects, challenges, so on and so forth. So I'm really happy to be here. I can't hear you.
So we'll be starting with some general questions, and then further on we'll move on to the attendees' questions. So we have a variety of people attending this talk. So can you just briefly start with some what according to you is the state of conversational AI, and where do you see it going into the future?
So Somesh, I think what is mental AI, talk about where we are and where we could head. So in general, there is a lot of buzz around this phrase conversational AI, and in general around the whole AI business as well. So conversational AI, when we say, it's basically we are referring to a set of tools and techniques which enable interacting with machine in a human-like language, right? So that set of tool and technique is what we call conversational AI. And there has been a lot of so like I have been involved with the general area of machine learning and broadly speaking AI for almost 21, 22 years now. But the growth of and the interest, both academic as well as more so from industry, that we have seen in last 10 odd years has been really much more than what it was the decade before it, right? So and the primary reason that there has been so much of buzz and so much of talk and so much of resources, both in terms of monetary as well as human resource wise, that has come into this field is because there have been some key development that happened in last many years, but they kind of fructify in last 10 years or so. The processing power being one of them, right? We have much more not so energy resource hungry. The chip sizes have reduced and the compute power has increased tremendously, right? So that has been happening over a period of time, and now we have ability whereby we can process millions and billions of tokens, right? So that's one key development that has happened. And then another thing that happened is, of course, the availability of the data itself, which has increased so much because of again, the revolution around internet and smartphones and social networking and social media. So the amount of data that we have is tremendous. And then the third thing, which kind of is also, which has happened, is around this whole notion of self-supervision, right? So I think many of you would be kind of familiar with basic machine learning and concepts that are involved around building machine learning systems. And the supervision, right, which is kind of training data, which is required, always restricted the amount of things that you could do. And this goes for general AI systems as well as conversational system. Conversation is kind of building conversation system is a key application under AI. And this whole notion of self-supervision has, which is kind of to give example of self-supervision, is more like you don't really need data to create training data, but it's more like to take the data and you can use this data in a interesting, novel way that you can create a self-supervision task, like take a sentence and mask certain words of it and then guess what those words are. You don't require any manual annotations to create those kind of things. And these kind of techniques like self-supervision paired with the huge resources around compute resources that we have and availability of the large data has really created this scenario where we can actually really understand a lot of different perceptions like images and speech and languages now. So, and that development has happened in last 15 years with such a rapid pace that people have tried to take these key developments and then try to build applications, different applications around search, around question answering. And as things move forward, conversation being one of the most complex phenomena, so then people have been trying to build these conversational systems using these sort of technologies, which have kind of come into horizon because of all these key developments coming together. So conversational AI, when we say it, basically we refer to all these kind of key concepts and technology, and then try to develop a conversational system around it. That's what conversational AI means. Now, there is also another phrase which is kind of very popular and seems to some people probably analogous, chatbots, right? So chatbot is also, it's kind of an application or an end product, which may or may not use conversational AI concepts. It may be very rule-based, but which is also have become very popular, right? So, and chatbots, many of us, I believe most of us, all of us probably would have interacted with one chatbot or another. We also have these examples like Siri, Google Home, Alexa, right? So these are all examples of personal assistant and then chatbots, which you would have probably seen on website. So these chatbot techniques and technology and a lot of development has happened over last 5 or 6 years around how to build chatbots, the framework to build chatbots, and then deploy them and make them available either on website or on WhatsApp or on Facebook Messenger or Insta and things like that, right? So there are a lot of things around these chatbots. And how does the chatbot and conversational AI come together? So chatbot is what you kind of, it's kind of an application which is using the technologies and tools that are under conversational AI to build them, right? So that's how chatbots kind of come into picture. Now, there is a lot of buzz around it today, right? And I think the experience that we have from these chatbots today is kind of, most people feel that a lot is more desired, right? It's not really where it should be. So while there is a lot of hype around it, and in fact, if you see things like Alexa and Google Home, people are actually using them. But they're far from being really interactive, really conversational, which can carry context across multiple turns, across multiple sessions, and can engage with a conversation which is really very human-like. So it's still far away from that, but they are still, they are very different than these other kind of chatbots that we are talking about, which kind of, if you go to a bank today on a website, you could see, talk to me, HDFC has one of them, ICICI has another, all telecom also has them, right? So, so those chatbots, on the other hand, they are kind of built using a set of frameworks. And these frameworks are kind of some kind of libraries and, a way in which a developer can take those frameworks and design these chatbots and develop these chatbots. Example of these chatbot framework being like Google Dialogflow, IBM Watson Assistant, Amazon Lex, Rasa. Right? There are these terms, these names that probably some of you would have heard, but basically these are a set of libraries and tools, and they provide a way in which you can create these chatbots. And these chatbots are in a very preliminary stage of their development today. And that's why their experience, overall experience, is not a whole lot. Like there is a lot more that you desire for them to be there. So, but it is still some good development which has happened over, I would say, Siri came like in 2011 onward. That was the first time when people at large actually kind of were able to experience something like this. And then Google Home came, and then Alexa came, and then now you have more and more these chatbot being experienced by all of us more and more, which are still in a very preliminary stage, and a lot would happen more and more. And chatbot is just one conversational AI implementation, like one particular application where conversational AI kind of technologies have been tried and have been used. But there are many other applications that we will see more and more coming. For example, the conversational AI kind of techniques are going to change the way we interact with machines completely over next 8-10 years. The pace is so high that I think a lot more things would happen in next 10 years. Right now, it's all very language specific. Of course, there are speech modalities, and there are very good voice recognitions now, so we could interact in voice. But image is not there right now. Gesture is not there right now. And these chatbots that we see today, which are either textual or in audio modality, we'll probably have more visual aspects to it. We probably have even more things which are augmented reality type, virtual reality type. Those kind of things are what would happen more and more, right? And that's kind of maybe another 7, 8, 10 years down the line, we'll have those kind of development happening. Even before that, there will be other kind of applications that probably will come in from conversational AI beyond chatbots. Things like customer care experience in industry would change tremendously. We will have a much better way of automating things. Right now, the chatbots are just responding back. They are not doing things, but maybe they will start doing things. So those are the kind of developments that I see, going to happen much sooner than 7, 8 years. They will probably, some of those things have already started to happen actually. So that's where things are proceeding now. But I think beyond next 5, 6 years, it's going to get into more modalities. It is going to be more contextual, much more natural, the way we talk with other human beings. And then, as things develop, I think there are more and more applications will come into picture, right? Where we can apply these conversational AI techniques. Another thing which a lot of research projects exist, like, programming computers using natural language. We don't need to really program using the high level and 4th generation languages like Python and things like that we do. Now it's still remote in future, but that's where things will move. More and more computers become that we have technologies that we can make computer understand using these natural languages. These requirements for programming languages will reduce, and we will have naturally programming kind of things coming up, right? So that's where things are moving. So they are moving towards more natural human-like conversations. They are moving towards more modalities and images and gesture-like things. And then there are these applications that are coming from industry, which are beyond chatbots, like assisting agents, automating things, and even things like going into fields and then doing things in a conversational manner, like you have inspections in railway engines and in big machineries, people trying to do these inspection. You can do those things conversationally. So those kind of things would happen. So that's how I see it moving forward. So that's a very, very long answer to the question, but yeah.
That was a very insightful introduction to conversational AI. You almost covered my second question as well, which was about how is conversational AI exactly different from just voice assistants or chatbots. So yeah, so okay. So for achieving,
maybe just to get more clarity, I think examples always help. Like, and finally, these are just words, right? There is no really very hard defined rules around that this is conversational AI and this is just chatbot. But in general, conversational AI is more like a collection of techniques, right? And these techniques nowadays, the things which are kind of prevalent are things around embeddings and the deep learning architecture that has come and which has created which has enabled us to represent words in a more continuous way, where we can actually represent words in what are called embeddings, which is just a fancy name for just a set of real valued numbers, which has a particular property that words which are similar are going to have similar set of real valued numbers, or they will have similar vectors. So the technology that is going to give you those embeddings of words, right? BERT being one of them, which gives you contextual embeddings now. And things like generation models that you have, where like GPT-2 and GPT-3 and things like that, and BERT, which are kind of going to help you understand things, right? So these are the kind of tools and techniques, not necessarily just like this, like in general, the classification technique, which, right, the modeling of dialogue kind of technique, things around speech recognition, things about natural language generation, things about, again, text to speech, right? So these tools and techniques put together, all those things are what are conversational AI. Chatbot is just an application which is using these things to achieve a specific task.
Yeah, thanks. So, okay, so next, I mean, for achieving like human artificial general intelligence, there are multiple tests like the coffee test, employment test. I mean, the Turing test says that if a human cannot distinguish between a human and machine significantly, the machine is achieving AGI. So, what do you think, according to you, are some of the biggest challenges or questions that lie as a barrier before conversational AI? Until we can really say that we have achieved AGI and that we can use it in the industry as well.
So this the notion of general intelligence is I think, to answer this question, right, we need to really have a very clear idea about what we mean by this whole notion of general intelligence and where we are with the notion of general intelligence. So if you look at the systems that today are built, right, largely built, of course, there are some exceptions to it, but they are built for a specific task. So you have things like sentiment classification, right? So you take a set of examples that have some reviews or some passage and say these are positive and these are negative. And then you take even things like BERT model, which kind of are some pre-trained things so that you have a better understanding of language, but then you're going to fine tune them using this particular data. And that model that you build will be able to do a good job for that task, but that model will not be able to do anything for any other task, right? So it's only specific to that one task. So that's why we don't call it general intelligence. And general intelligence differ from this notion because it's a system which could do thing A, then it could also do thing B, right? So humans are not like that. They can do a very good job of sentiment classification, but they have absolutely no notion of doing something else, right? So that doesn't happen. So, and we actually are kind of moving towards that now, given this whole notion of pre-training and fine-tuning. And I don't, I'm not very familiar with the background of the audience here, but I do think that people would be familiar with this notion of pre-training and fine-tuning. But to just give a two-line summary of this thing, basically, in the context of language, what we are trying to do with this pre-training, and there are other notion of pre-training as well, but you want to just understand what words mean, right? Each of the word, what they mean. And the pre-training could be set up in a way that you learn what each of the token mean using some task. And these tasks are typically self-supervised tasks. And an example that I took was what are called masked language model, which is what is used by BERT, where you kind of, remove certain words and you try to guess those words, right? So those kind of tasks, when you do on a large amount of data, that is what you call pre-training. And that pre-training gives you a good way of representing each of the words. Now, given that pre-training, you need very small amount of data to really do a good job for any specific thing, right? Like sentiment classification. So the model that you build still will just do the sentiment classification, but this pre-training thing could actually help you do any other thing very easily. So you're moving in that direction now, right? In fact, there are even further development with GPT-3 that you don't need to fine tune anymore. You just need to give one or two examples and you don't need to train them. And this probably will be, it may require understanding, this may require a little bit of more context, but you don't require fine tuning for a specific task for building systems that will do a specific task anymore with systems like GPT-3. You just can give a couple of examples and it will just learn to do those things. Now, those are the claims being made, and I myself have seen instances of those to some level, but we are moving towards that thing that you don't have to really fine tune for specific tasks like sentiment classification. With GPT-3 thing kind of systems, which have been already kind of pre-trained on a really, really huge corpus with a really, really billions of parameters being in there, you could just give it two examples of one with positive, one other with negative, and that is it. That's all. It's the sentimental classification is ready there. You don't have any training to be done. Now, that is moving towards this whole notion of general intelligence. So we are moving towards that. There are a few instances of this now, but there are many challenges. There are many, many challenges with these systems. We are nowhere being to a point that, you know, everything is solved, let's go home. No. GPT-3, for example, generate things which are today are very difficult for humans to say that this is not human generated. You actually cannot say that. It's very hard. In fact, 99% of people will not believe that it is not written by humans, but they would have factually incorrect things. So they really can't be used because, and this is what is known by the name hallucination. These pre-trained large language model like GPT-3, they suffer from hallucination. They cook up facts which do not exist. And it may be very hard for a normal human being to really catch those things, but they do suffer from that, and that's one of the biggest hindrance today I see of their actual deployment in real world. So we need, and this is one of the, I think, key problem today being faced by these systems like GPT-3, and we want to ground their generation, we want to ground their behavior onto something more concrete, something more factual, and, you know, have some ways of controlling them that they do not hallucinate. So I think that's one of the key problems that I see today. The another problem is, of course, the amount of data that is being used by these models and the amount of compute resources that are required to build these is simply unattainable by everybody except 3 or 4 industry enterprises. They are huge, right? So we need smaller scale, something which can be trained by other people as well, right? So that's another key challenge which people are looking at. So I think these are some of the things that where we need to innovate more. But we are certainly moving towards things which are seeming to feel like, you know, general intelligence, but they, of course, they are still a lot of, like, you know, and a lot of problems there, but we are moving in that direction for sure.
Yeah, thanks again for the insightful explanation. Moving to some audience requested questions, like, so for an undergraduate who wishes to pursue a career in research and conversational AI, what is the way to go in your opinion? What courses should one person take? How should the colleges update their curriculum to facilitate the change in the industries? So some thoughts on that.
Yeah, so if you look in the industry today, most people have learned on the job, right? These developments of deep learning, language modeling, ImageNet, all those things happened in the last 10 years, right? And most people have learned them on job. So I think one of the key things that today, whatever you will learn, 10 years down the line, things what will come would be very different. They would certainly be different. So we have to have, I think one of the key things that everybody, as a student, everybody needs to do is to have the ability to learn quickly. I think that is something which is really, really very, very important than any specific thing. Now, specific things will be important for in the context of today, but that context would change, certainly change in 5 years, 10 years down the line. You need to have the ability to learn quickly things, right? So I think that is a skill, that is a habit which everybody needs to really have and inculcate and keep as well, right? Because as you age, you tend to lose that more and more. So I think that is one key thing that is non-contextual. This needs to be everywhere. But in the current context, what are the things that are good to have? Now that depends on the kind of career choice one has, right? So everybody is not going to do research, right? Of course, so the answer will differ depending on, you know, what is the aim that you have. Now, there are people who would be probably more interested in building real world system, being in the industry, being more on development oriented, being more with clients, being more with real things, building things which are used by many, many people, right? So there is one track on those kind of things. And there, of course, you need things like Python is anyways required everywhere, right? Because that's more like a language that you need for whatever you do. Now, so that's definitely one thing that you would need, irrespective of what you want to do, whether research or development. And then you need to be more familiar with these bot frameworks that you have, right? Things like Dialogflow, Watson Assistant, Alexa, not Alexa, the Lex. Amazon has a framework called Lex, and things like that, right? So how do you take these frameworks, use them to create assistant and bots and connect them with speech and connect with different languages and so on and so forth. So there are those kind of things, right? So, but if you really want to understand the basics of it, which is always helpful, even if you're doing these things, if you know the foundations of these things, it's always good. And if you want to do things in research, you certainly need them. Then you definitely need to be very well versed at the conceptual level, what embeddings are, what are contextual embeddings, what are transformer architecture, what are generation kind of things, right? So these are more like at the basic tools and techniques level things, which are what is very, very useful, seems to be. In fact, nowadays, it has become very simple. So in 2000 and before that, right, if you used to see these machine learning papers, they used to have many different ways of doing things. There were many different room of innovations. In fact, it is less and less restrictive now. You just take whatever you have, put it into transformer, and that is it. There is not much to do nowadays, because that seems to work everywhere. Of course, there are other challenges, but so being very well versed with transformers, being well versed with BERT, GPT, all those things is something which is really very useful and helpful. And then taking these techniques and applying them into speech, applying them to languages, that's where the next set of things come. And then images is another thing which has always been actually at the forefront of development of all the machine learning, actually. But yeah, so bringing the images and the conversation and the video coming together, those kind of things are still more and more in exploration. But I think students' perspective, getting your fundamentals and foundations very solid in terms of knowing about transformers and the key development around BERT and GPT and things like that would be really very, very useful from an industry perspective, from a development perspective. Knowing about all these different frameworks, how they integrate with the enterprise systems is going to be very helpful. Of course, your knowledge and your expertise in Python is going to help you at every place. So that's something that you should definitely be doing. Yeah. So these are some of the things that would be helpful for making a good career in this.
All right. So yeah. So like in search of like machines that communicate in natural way rather than just rule-based chatbots or primitive applications, recent research has shown that these neural dialogue systems, they need to be more firstly interactive and use conversational history very well. And recent development in transformers and large pre-trained language models, do you see them fitting into this scheme? Because there has also been recent work which shows that at some point of time, even disrupting the conversational history a lot, like these models may not be doing that well. So how do you think these models fit into that scheme?
Hello, can you hear me?
Yeah, I can hear you.
Okay. So I had some network problem, but so some last part of the question I didn't hear, but you were talking about the development in neural network and the context of the conversation history being long, something of that sort. Could you please repeat the last part?
Yeah. Okay. So basically, it is seen that in neural dialogue systems, like interactiveness and using the conversational history are like two very important aspects. And how do you see transformers or these large pre-trained models working around it?
Okay, so conversational systems could be of many types actually. There is one type which is, I think people are more familiar with, which is about what are called open domain, right? They are like, you can just talk to them like you talk to human beings, right? So that is one category of conversational system, which are open domain. You can talk to about them anything. They don't do anything specific, right? But then there are other kind of conversational systems. They will do one specific thing. They are called task-oriented dialogue, like something which will help you book a restaurant, something which will help you book an appointment at some place, right? So, or reserve a seat on plane, right? So there are some tasks and that will help you do those tasks. So, and neural dialogues have been applied on both of them actually. Of course, people apply them everywhere they can. So, and at the open domain level, things have moved really good actually. So people have taken huge amount of conversations. Okay, now there is also, this is again another example why we could do this today, because there is so much of conversational data which is easily available on discussion forums like Reddit. Reddit have billions and billions of tokens coming every year, which are conversational, right? So there are a lot of companies like Microsoft, which has Dialog GPT, Google, which has things like Meena or Lambda, Facebook, which has something called Blender, Baidu has something called Plato. So these are the systems that have taken billions of tokens from Reddit conversations and trained them on transformers. And then you can engage with them and just, how are you doing? And they will have something to say nice. And then you say, okay, did you do like tennis? They will have something to say about that, which will be relevant, which will sound fine. So you can just keep chatting like that, right? But they won't be doing like, okay, I want to book a restaurant of South Indian in some place. They won't be able to do anything like that, right? So that's open domain. The task-oriented domain is more where you, as I have already given examples, right? So now the challenges of these conversational things is that the dialogue context could be very large, right? Now, it's very technical or very deep level thing, but Transformer has a restriction of 512 tokens, right? And why do we have that? Like, you can always increase it, but there is some limit that's going to happen. And you can only analyze that. And there are ways in which you kind of, get around that thing also. There are many ways in which you could only have a window of 512 tokens and still do things with sliding window. There are something called long formers. There is something called reformers. So there are a bunch of tools, techniques that people have developed around it to work with bigger things than just 512 tokens. But it still will be a problem if your conversation context can grow long, really long. The reason is that we don't have a notion of state that very well. Like, so in these task-oriented dialogue systems, we have a notion of dialogue state, which is very crisp. Like, this is the goal of the task. These are the slots that need to be filled. Like, book a restaurant is the goal. Type of the cuisine is South Indian. Price is expensive, right? So no matter what the length of conversation is, the context of the state of the dialogue could be enumerated like this. But when you have this open domain thing, right? The state of dialogue is not that well structured. We don't even know what it is, right? So you will get into that problem. And then you may actually kind of contradict what you said earlier, because you don't even know what you said earlier, right? So because it has gone much beyond 512,000 tokens, whatever the limit is. So those are some of the problems that people are still looking on, how to get around with. But so I think that the question about how well the transformer kind of things would be able to deal with these huge, large conversation history, there are limits today. There are ways that people are working towards to remove those limits, but we are still not there. As far as task-oriented dialogues are concerned, that has this notion of dialogue state, which is much more well structured and has less of this problem. So that's how things are.
Yeah, great description on the technical side of these things. So one more thing that I wanted to ask. So basically, what are the major industries' views towards linguistic inclusivity? So there are a lot of challenges over there. So let's say for English, we have a huge resource for English. Then we come to Indic languages. We still have a lot of resources for them. But then we come to some languages that we don't have really a good source for to learn. And apart from this, there is code switching, script mixing, and we have people with disability. So how are industries planning to cover these aspects?
So that's a very good question, Somesh. And in fact, it's very, very pertinent. I have come across at least 2 clients in last 1 week who had a problem. One was a Punjabi bank, and another was this bank which is more popular with Telugu and Tamil. And so there is this problem of resources, because in fact, one of the things is that while there is a problem, but it's not that big a problem, because you are not required to have any supervised data. All that you need is data, right? So you could learn these models and they are not language specific, right? So this problem of languages was a huge problem. It was a big bottleneck earlier, because we had technologies like parsing, right? Dependency parsing or syntactic parsing, and somebody has invested tens of years actually in creating those rules of syntactic parsing and dependency parsing for English language, right? Now we can't continue to do that for all the languages, and even the languages which are really not that popular, right? So, but with these self-supervised things, right? All that you need is data. You don't need what are called resources, right? Because resources is something that somebody has put a lot of manual effort or done something. Now you can take data. If data is available, you can actually learn these things, and then that learned thing themselves become resource. So you can build a BERT model of Punjabi if you have Punjabi data. The problem is, for some languages we don't even have the data in digital form. That is a problem. So I think the problem has still reduced significantly what it was earlier, right? Earlier, we didn't have syntactic parsing mechanisms for Punjabi or for any other, like for any language. Like it has to be built, and somebody has to put really a lot of human effort in building that. So that problem is not there. Now, it may happen that you don't have enough data. There has been also a lot of exploration and research around how we could use similarity of languages themselves to learn, right? So, for example, taking the example of Indian languages, a lot of languages have commonality. They are called Indo-Aryan languages because their root is very similar. And we have seen, actually, we have in our group also, we have that kind of work happening, because in IBM research, we do have a special focus toward Indian languages. So we have been working around doing things with Indian languages. And we recently had this work where we showed that if you kind of learn for multiple languages together in a single model, and these languages being Indo-Aryan languages, you are able to learn much better with whatever data you have than learning these models separately. Because you are able to learn across languages when there is some similarity in those languages, right? So those kind of ideas have been being explored to come up with, right, to get around the problem of less amount of data, because if you can get data from similar languages, that help. And this is just one point, right? But there are other kind of development that are happening. But this problem of being able to do things in other languages actually is much more doable now than what it was earlier. You also brought another point about code switching and code mixing, and that is a very real problem. People don't say just so, like people who talk in Hindi, they talk like 40, 50%, 60% of their words are actually in English. while even talking in Hindi. And so there are a lot of new challenges. And when I say challenges, I mean challenges in terms of leaderboard challenges that have been come across in last 1-2 years. In fact, we ourselves in IBM Research, we had a special workshop on code switching in interspeech this year. There is also another leaderboard from Microsoft called Glucose, which is exactly around the problem of code switching. So these leaderboard and workshops, and these are like some organizational structures, some mechanisms, some logistical mechanisms to get more efforts and research driven towards a special aspect of it. So I do see both from academia and from industry going towards these kind of problems of low resource languages, as I see many more workshops coming around these things, we ourselves being engaged in those kind of things, as well as leaderboard being floated by industry around these things. So and then I also see direct research work around things where people are looking at how to do things around low resource languages, and there are some innovative ideas around that. So the thing is not solved, and in fact this is a very good opportunity for some students here because they are still in papers. There is nothing real here, right? We need somebody to take all these ideas and actually build these models which can be applied in building WhatsApp bots and other kind of bots because there are only very few people who speak English in India. So we do need some of you to actually take on to this. And this is more of I would see this as actually a very good engineering and business opportunity in front of us today because we know how it works. And it's just a matter of doing for somebody. And somebody will just definitely do it. Of course, somebody will do it. So it's a good opportunity in that sense.
Yeah, that's a really great cue as well. So yeah, thanks a lot for covering these questions of mine. We also have some questions in the chat box if you want to take them. So yeah, so the first question comes from an ethical aspect. So the person says that recently there was an episode where Alexa accidentally called someone. So what do you think are the limitations of conversational AI in these ethical aspects, which can threaten human lifestyle? And what are some ways to take just some general ideas on how companies are getting around it?
So in general, there is this problem of ethical issues around AI systems, and conversational system is no exception here. In fact, one of the instances, I think one of the earlier instances around this was when Microsoft actually deployed a conversational system in 2016 using Twitter data called Tay. And when they trained the system, they had made sure that they do not use abusive language. And because they filtered out that data, right? So with all machine learning system, garbage in, garbage out. So the model will learn what the data has. And so they made sure that they don't learn abusive thing, but they also had an online learning capability with this bot and this Tay system. And within 24 hours, Tay was abusing. So that was, I think, one of the first instances around conversational system that I can recall where such a thing happened, and it had a very wide press coverage. So this is a real problem because there are also problems around biases, right? The conversational. So, for example, nowadays everybody is using Reddit forum being one of the popular data, right? And people have biases. The society have biases. That bias is reflected in the data as well. And if we use that data to build systems, they would have biases. There is a lot of work happening around how to remove these biases. That is a research area of its own. And then there are, of course, industry services and applications and frameworks that I see industries putting out, which kind of detect these kind of biases in the system beforehand. So there is a lot of work around that too. So I do see that problem of biases, but one of the ways in which I see industry actually getting around this problem, and it's not a bad way, is the following: that so when you generate a response, right? So what is a conversational system doing? A conversational system is taking whatever you have said so far and then giving you the next response, right? That's what a conversational system is doing. Now you could do it in two ways. You could either generate word by word, right? So you can take the conversation context and then you can generate a response word by word. That's what you could do. But there's another thing that you could do, which is if you have a pool of responses, right? And those pool of responses could be in tens of thousands or hundreds of thousands or even millions, doesn't matter. And you have to select one response that you could apply here, right? So that is another way that you could do it. So I see, for the practical reasons and for the reasons like what you just said, if the application of your conversation system that you have could be done using this set of predefined responses, then that's a good way, because then you have a very good control. Then you know what my system is going to say. You may have thousands, you may have million things. Now, million will be very difficult to manually verify, but even tens of thousands of responses are not bad. If you have tens of thousands of responses space and you select something which will be applicable in a particular context, then that's good. And then there are also other approaches which kind of take these pre-selected things and then can edit it in some ways so that it gets more personalized with the dialogue context that you have, right? So there are those kind of approaches also. So now this is what I would say is a stopgap solution, right? This is how we can work today and can actually put systems practically open and not be worried about that God knows what my bot is going to say. Of course, the chatbots that are there on websites are being built in a completely different way. They are never going to say anything which is not warranted, which is unethical, because they have only a handful of things and it's all rule-based. So it's not going to do any of that stuff. I'm only talking about machine learning, deep learning based conversational systems, which have this flexibility and which has this degree of freedom of saying whatever you could say in those dialogue contexts. So, but you could restrict it based on these kind of things. So that's one thing that you could do. I also feel another problem, which is not ethical, but which is not inclusive, is that is coming more because of these large scale models, which make I don't see any university having those kind of resources, right, which are being used for creating these kind of language models and conversation models like Plato and Mina and Lambda and Blender. It's impossible. So it is kind of creating an exclusive set of people who are able to do it and then further research on it and make it even better. So that is a bigger concern I have, and I don't have a good solution for it, but there are efforts in terms of trying to build models which do not require that much resources, but that is hard work. What we have seen is it's very easy to make better system by throwing more data and throwing more parameters. And that is very easy for somebody who has resources. So the growth has been tremendous with that single idea, more data, more parameter. That is the only innovation from GPT to GPT-2 to GPT-3 to probably GPT-4, or from BERT to T5 to, there is no innovation. That's all what it is. More data, more parameter. So people who can do it will keep doing it.
This answer actually covers a lot of the other questions here as well. So I'll just try to merge them. They are basically based on scalability. So basically people are asking, so do you think if we have a method of like, so if there is a way of scaling these language models, so is that the only thing required to as a paradigm shift in conversational AI, or basically how is industry and academia going to counter this parameter race, basically?
Well, parameter race is, of course, there, which I don't think that is going to settle very easily, because I do see it's a very easy way. It really works. If all that you have to do is to get some more 100 GPUs and throw more data, then people who do it will definitely do it. But I do see there are many problems in taking those systems and deploying them. It's not going to happen that easily, and that is a bigger problem. So you see, there is a big gap. There is a big gap between these deep learning based models that you have and the chatbot that you have on a bank's website today. They are far apart in the technology being used. They are very, very big gaps. Okay. And I think there is a lot of work which is already happening and would happen more to bridge that gap. So, and that is one of the things that actually we in IBM has been, and my group personally has been involved in bringing these advances in deep learning and bringing them into these chatbot frameworks like Watson Assistant, right? So, and there are ways. I don't want to get into the internal detail. I would be happy to discuss if there is interest on how we are doing it. But those are the things I think where more work is needed, which is how do we take these large-scale pre-trained systems and then make real deployable industrial systems, right? And there is a lot of open field here. There is a lot of space here to work on. So another problem is, so for example, right? So when you go to, you have built these bots, right? These large scale models, and then you go to a company, and then company say, okay, here are my documents. All that, the way we operate, our processes, our policies, everything is there in these documents. Now, could we take these large language models and take these documents and now build a bot who actually do response generation based on these policy guidelines and the procedures outlined in these documents, right? Because a bot trained on Reddit open source discussion forum is not useful, right, in that bank's context. So if we can take these, but these models know how to converse. But now can we take that general capability of being able to converse and ground that conversation into the context of the enterprises? We don't have anything that can do that today, right? It's a good exploration. It's a very good thread to look at. I do know there are some movement in these directions now happening, but those are the kind of things that are needed, I guess, and that are, unless we have those kind of mechanisms, we could develop more and more parametered models, but they will not be useful in real settings. They will not be useful in industry. For making them useful in industry, we need these conversational systems to be in the context of the company. And that's, I think, is a very good thing to look at.
Yeah. Just 1 second. Yeah, my bad. So we were earlier talking about towards the starting of the session that apart from just text or speech, we need multiple modalities. You have gestures, you have emotions. So basically, do you think an advance in the fields of like AI, VR, and augmented reality, are these going to help? Is this going to be something big in conversational AI in the coming age?
Oh, absolutely. There is no doubt about it. These chatbots that we have, which are text-based today, and you of course have the speech modality on top of it. You would have them integrated with images soon. And then you will have the augmented reality and virtual reality, and you could pretty much have the holodeck kind of experience in next few years, right? We are moving towards that. And I know that companies are very seriously thinking around these ideas of integrating conversational AI and VR and AR. In fact, they have research teams set up around these ideas now. So, which basically indicate that the conversational aspect need to come with different modalities, and then augment further with the other reality that you have, right? So the applications like holodeck, and you are a character in that holodeck, and you are interacting with these other things, and there are gestures happening, and there are images moving, and all those things are going to come together. And it is pretty fancy today, but it is something which seems is going to happen not too far in future.
Yeah, that's great. So we have just one final question. I'll just merge this. So what do you think is missing in these modern language models like GPT and all, that is sort of stopping conversational AI to or chatbots in these transformer or large pre-trained models? And is there some way to share the context between some previous questions asked to these? So basically, earlier we discussed about neural dialogue systems based on log history or conversational history. So apart from this disadvantage, because you said that there is a limited tokens, like 512 tokens that are going to work, and at some point of time there will be some limit because it will be trained in that. So are there any other issues, and is there any way to stop them?
Actually, I think there are bigger issues. If you look at any real system deployed, the machine learning model is very small part of it. It is actually not more than 10%, maybe even less. The complexity of deploying these models into industries is humongous. And it is, I think it is that aspect which has a lot of potential in terms of things to do. These model innovation is one aspect, and we talked about how these models are becoming better and better, and how we can take them and create these applications and conversational applications. But then when you take these conversational applications and then you deploy them in industry, the infrastructure around it, all the application, the enterprise application in which this thing is going to sit, that is huge. And this particular thing that we are talking about, that we spend all the time talking about in last 1 hour, is not even 10% of it, right? So how do you take these models? Because when you have these models and when you have these practically deployed, you have a lot of problem around management of this model, building of this model, updating of it, right? Testing of it. So there is a lot of infrastructure as well as a lot of code and support that is required around these things. So how do you make it simple? How do you make it easy? I think those are some of the aspects which are also very interesting, which people do not think naturally about, but which are very real and which are definitely needed to be solved for these things to, and these developments to affect in our society as much as they can. So model innovation and how to solve these problems, like the things that we talked about, are important. But even more important, in my opinion, are these other aspects of how do you make them simpler to deploy, and how do you make them work with other part of the entire enterprise software and things like that. Management around models, how to keep them building up, continuous improvement of that, so on and so forth. So those are like coming DevOps with how do you integrate these things with these models now, and deployment and building of these models now. So those are some of the other things that I think are very important to do in near future.
So basically, research needs to go in hand with the engineering aspect, and that is even a greater issue right now.
Yeah, absolutely.
So I think we are done with the questions. Thanks again, once again. Thanks a lot for attending the session and answering all the questions so patiently. I personally learned a lot from you today, and I hope everyone did so as well. Yeah.
Thanks a lot, Somesh. I'm again very happy to be here, and please feel free. If anybody has any queries or questions or any suggestions that they want, please, I will be happy to take them. Not just now, but even later. Just email me.
Okay. Thanks a lot.
Thank you.
Yeah.
Bye-bye.
So, Vedant, I guess we will be closing the session.
Yeah, sorry. So thanks everyone for attending the first session of the AI Symposium. So the plan for the rest of the days, we have a social at 6 p.m. I think all those who applied for the social till 12 o'clock last night or sometime after later that, and those who have been accepted have received the invites. For people who applied afterwards, we'll go through the process screen, and if you're selected, you'll see an invite on your calendar list with the Gather Town link in the same invite. So okay, looking forward to see you there. And just a reminder, so this is a 2-day event, so we'll also be having the second and the third sessions tomorrow morning and evening respectively. So and we have an amazing lineup of speakers planned for that. So yeah, looking forward to seeing you there. Thanks for coming.